get started. So why are we here today? We are learning about how SD access applies to manufacturing environments. And this is not a bribe, the candy, but the idea is this is not an easy topic. Like SD access for manufacturing comes with some caveats. So I am not too sugar-coated. Yeah, so I'm giving you a sugar in the form of chocolate. I'm Erica Franco. I'm a solutions architect on the IoT Solutions Engineering Group. And my work is to build architectures and make sure they are validated in our lab in RTP, so we can produce Cisco-validated designs, and you can deploy this with confidence. I am from Colombia. That's also where my accent is from. So if you have any questions, if you don't understand something, don't hesitate to ask, and I will repeat it for you.
Yeah, OK. I guess I also have to introduce myself. My name is Thomas Kemper. I am with Audi, working as a solution architect. Happy to be here. Flew over from Germany, so there will be no jokes today. I'm sorry. And also, we will not be talking about cars, but actually how we produce the cars. So if anyone came here, want to hear anything about cars, yeah, sorry for that. OK, over to you. Yeah.
Good. So if you haven't done so, please join the app, the WebEx group. If you have any questions and you want to ask them after the session, we will answer. Not during the session, though. I mean, we will take our time in replying to you. So let's go over the agenda. So what we will cover today is first, what are drivers to put SD access into manufacturing? Then we will call to what I call the tale of four factories. And this is how our customers are deploying SD access in to cover different use cases into their environments. And then I know some of you came because of the summit, so then we will cover the Audi case. It's not only about the Audi case. So we first cover the tale of four factories, but if you are patient enough, then it will go to Thomas to cover what Audi is doing. And then we will talk about having shared or separated IT and OT SD access environment, benefits of each. And then we will move on how to use the network as a nervous system for your, to be able to run these operations efficiently. And then we will see some challenges and how we address those with SD access. So as you see, this is a session that is very packed. If you have questions, I will prefer for you to wait until the end. If we have time, we cover. I doubt it, but we will be here anyway, so we can cover them one-to-one after the session. So first, we want to start asking, like, take your phones out and let us know if you come from IT, from OT, IT for OT. I don't know if OT for IT is a concept, but whatever, or any other option. So Thomas, what do you consider yourself?
I consider myself mostly IT for OT when it comes to the technology that we are applying. We'll see something about that later on. But also when it comes to like the cultural shift, et cetera, it's also to some degree OT for IT, because we have to translate the requirements that we have, give them to our IT experts, and they will make whatever they're doing best, some good IT stuff. Yeah.
Good. So 5 more seconds, maybe.
Maybe you can bridge that by saying what you are doing.
I think I'm at IT for OT also. Working at Cisco is an IT company. So it's a different, we are not manufacturing like a manufacturing facility as you, but I feel I struggle a lot sometimes to get the OT message across Cisco. And what I learned from you, I try to bring it in so it can be incorporated in things such as SD access. So let's see. OK, wow, this is a tie. OK. Oh, I'm surprised so many IT for OT in the responses, right? So let's see, why you should consider SDA for a factory. What are the benefits of SDA? So I think the first thing is SD access is an architecture that is controller-based, and it provides intent-based configuration. So through a UI, you can deploy your network configuration and be consistent pushing that across your whole network. So that's really speeds up automation and simplifies implementation of networks. And with this, we can enable quickly new services. For example, we need to configure, we are working in a new data stream and we need to create a network. So we go to a UI, we quickly deploy a new virtual network or a new IP pool, and then that gets pushed across the devices, and you have immediate access everywhere. Then we can also leverage the segmentation that SD Access provides. And this is very beneficial for cases in which we want, for example, to run different services. In the campus network, we are running the building management system and the IT on the same network, but they are completely isolated. We can take these benefits back into manufacturing and have some IT and OT services running on the same infrastructure, but completely isolated. And this is very appealing for some of our customers. SD Access simplifies the deployment of security policies. TrustSec is not the only way that it can be deployed, but it certainly simplifies that, so that's also appealing for some of our customers. And because SD Access runs over layer 3 networks, we minimize the possibility of loops and the effects of a spanning tree. So this is also appealing for some customers, especially the ones that have been running for a long time with plain layer 2 flat networks. SD Access uses VXLAN, and VXLAN gives us the capability of extending layer 2 networks. So now I can have 2 endpoints talking, for example, Profinet, but they are in different locations, running over a layer 3 network by communicating on layer 2. And this allows virtualization of assets, and that's what Thomas will cover in more detail later. But before we jump in, we want to know from you what are your critical considerations? What is important for you in a network? What is your most critical thing? So Thomas, what is it for you?
So I'm a networking guy, so I will say resiliency against failures. That's, I think, the most important one, especially coming from looking at the OT side. You don't really want to disrupt any production with any kind of unplanned or planned failures, right? Planned failures is maybe a bad term. Then what else might there be? Probably security. This is kind of a boring topic for some people, for others, the most interesting thing in the world. Yeah, I think these are the 2 main points that I see. And maybe lastly, because we are, okay, maybe they're following what I'm saying, perfect. The last one that I see is real-time communication, because we have more and more applications that require low latency, and that in a deterministic way. So that would be probably my third one.
Thanks. Yeah, I like visibility. That's a big one for me. So let's see. So before we jump into how we can do SD Access for manufacturing, I wanted to review what we have for when we have a non-SD Access network. And for years, we have been recommending this architecture, which is proven, is validated. It keeps working for most of our customers, and is based on the Purdue model of automation and control. So if you are not familiar with the Purdue model, it provides a layered way to segment and organize industrial automation and control systems. And from top to bottom, we have first the enterprise network at the top. Then we have an IDMC layer that provides separation between IT and OT environment. And that's key for these environments, because this gives you a security you need, right? And then we have the industrial zone, where we run the industrial data center and the applications that are needed to run the manufacturing environment. And in the bottom, we have the cell area zone. This is where we have the sensors, actuators, robots, and where we have the industrial switching. So this is mostly layer 2 networks in this part. This is a proven architecture, and we have Cisco-affiliated designs for that. So when we jump into how do we meet the requirements you were saying that I already met by an architecture like this, how we could meet with this with SD access. And this is an example topology, not the only one, but I want to highlight some things here. If you see there is not enterprise layer and industrial layer anymore. In this example, we have an SD access fabric that provides in yellow the industrial network, and in pink, we have the enterprise network all on the same fabric. So we don't have this physical separation between IT and OT network anymore, or enterprise and industrial network anymore. In this example, this is not the only way to deploy SD access, by the way, but doesn't mean that we don't have the Purdue model anymore. And we struggle sometimes with this question. If we are going to be purists in Purdue model, of course, this is not exactly matching. But if we are thinking from a logical perspective, this still gives us the logical separation between the layers in a shared infrastructure. And granted, this doesn't satisfy all the use cases. There are some industries that need to have completely separated IT and OT. But we have seen this as an appealing case coming up. So we have the logical separation enabled by SD access. And the communication between these networks is policed by the firewall on the top, which is the peer device in this case. We can add multiple virtual networks. On top of that, we can have a building management system. We can have a virtual network for IDMC, so there are some jump hosts to access applications. We can have many of these, what we call overlays in SD access, that are completely isolated from each other. But if you notice something in this architecture, how we are starting in this journey, the cell area zone is almost unchanged. So we are changing how we connect to the industrial zone, but that's almost unchanged. Another thing to call out is this architecture also allows us to have like services on site. You see, we can have a local cybervision, local WLC, local PSN for ICE. So the site can survive in terms, it doesn't need to rely on the shared services if there is a disconnection. So with this in mind, I will move to the tale of four factories. This is where I want to tell the story of how we deploy SD access for different use cases. Because also, we are not pushing a specific architecture. You have to do this in SD access. It depends on what you are looking for. For this, and before I tell you the four examples, the four factories I have as example, I want to get into this mindset that SD access it's based on your needs. So for that, there are some decision points along your journey that you have to make to see what is the kind of deployment you will end up with. And the first decision point is actually, do you have the drivers to implement SD access? Because it's not about the technology. It's about having a network that works for the use case. So if you don't have the drivers to go to SD access, then you can keep your network in non-fabric. And we see this in cases when there is not a strong need to have this shared enterprise and industrial network, or when there is not really need for intent-based configuration, because the configuration is very static and is pushed, workflows are already established. So if there is no drivers, we don't need to jump just for the sake of the technology, right? But if you have these drivers, then you want to start considering SD access, and this will take you into the upper path of this diagram. The next question will be, how far can you go with SD access? So if you have this operational environment that you already have workflows that are running certain way, and you have tools that you use to manage your switches, and you have processes to replace the switches, for example, with SD cards. So how does SD access fit into this picture if you are not too flexible to change those workflows? So in this case, what we recommend is your SD access network should land, as in the diagram I was showing before, on your fabric edge. And you can keep your layer 2 network with exactly the same, managing exactly the same as you were before. So this is the decision point in which the boundary is at the fabric edge. But if you have all the flexibility, and I come this dreamland because I haven't spoken with a customer in OT to tell me I have all the flexibility. But if you have all the flexibility, then you can consider, okay, let's do policy extended node, and better maybe for some, we are starting to explore, just as a hint, it's not part of this presentation, what does it mean having an industrial switch as a fabric edge on this architecture? So I want to highlight that the most common deployment we are seeing is where the boundary ends at the fabric edge. That's the layer 3 demarcation. And then you have your OT network is layer 2 below that. And then we have one more decision point I want to call out, and is where is your critical traffic flowing? If most customers will tell us, we want the access for the connectivity to connect to a SCADA server to get telemetry out of the cell area zone, but my Profinet, my Ethernet IP, is running inside the cell area zone. I don't need that traffic to flow through the fabric. So if you don't need that traffic to go through the fabric, we will have an architecture similar to the one I presented before. We call that single fabric. But if you have requirements for that traffic to flow through the fabric, then we need to look for redundancy, for a redundant topology that will make sure you don't have downtime. And this is what we will cover with the Audi case. So then moving to now the tail of the 4 factories, I have 4 fictional factories here. They are fictional in this PowerPoint, but they are real. I just cannot display the names of my customers. So the first one is Spanning Treats. They make snack lines without loops, without crumbs. Then we have Acme Corp. They produce high-speed robotics so fast that you cannot even test it before selling them. Then we have Ping Me Later, which is an alerting system programmed to alert eventually, and Nullbyte Ventures, which produce physical enclosures for virtual assets. Each of these 4 companies is based on reality, and I will tell you what are their needs and what is the model we are recommending for them. So the first one is Spanning Treats. So when they come to us, they had this problem because they were hacked. And they had to now implement some process, not only in the cybersecurity side, but also in the network deployment side to make sure all the switches were compliant with certain configuration. But they want to keep the Purdue model as they have it. They have very static configuration. They don't have any requirements of extending the fabric, extending the layer 2. So for this case, we're looking only for automation and assurance. And I know this is an SD Access presentation, but because the architectures are based in use case for this customer, we say you don't really have a need of the SD Access. You can keep your network as it is, and then introduce Catalyst Center. With Catalyst Center, you can have this automation, this assurance you are looking for. You can keep your Purdue model as it is, but you are speeding up your deployment and having the visibility into the network. Obviously, the con of this model is you are still operating the network with templates or with switch-by-switch configuration, or other in-house automation also sometimes. And it provides limited IT-OT convergence, but this is exactly what they are looking for, so is what it suits this customer. So in this journey, they went for the bottom path and stayed non-fabric. But now we move to Acme Corp. And they have an IT department that is really familiar with SD Access because they have deployed SD Access in the offices. And now they want to extend this into a factory floor and start doing a converged IT-OT infrastructure. Nevertheless, they have an OT team that doesn't want to use the same tools and IT, or they don't have access to those either. And when we ask about the traffic considerations, they want to keep all the traffic in the layer 2. They don't need that traffic to flow through the fabric. So for them, what we recommend is you can have your SD Access fabric ending in your fabric edge, that's your distribution, and then your OT network can be attached to that one and keep the same operation you have, the workflows you have on the OT. This requires some cooperation. I won't say they are completely independent teams. If the OT network needs to, for example, a new service to be enabled, the IT team needs to create something on a new overlay and give that as that's configured on the trunk downlink, and then it's available on the OT. So because of this, and also because they have they are using shared infrastructure, I cannot stress enough the success of this architecture depends on OT and IT teams working together, collaborating, communicating, especially when we are talking about change management. Because if there is a change in the IT space in a shared infrastructure, this can affect OT. So it's very important. This is mostly more than a technology issue. For me, it's a cultural issue. We need to bridge that gap for this architecture to work. The downside of this architecture is we are not benefiting of any automation or assurance in the OT side. So when we are at Cisco, we try to push these customers to move to the model of ping me later, which they are similar to the previous one. They have an IT team that already implemented SD access. They want to have a shared infrastructure, but they are more flexible in the workflows. OT team is eager to adapt some of these IT workflows to be able to manage the network. So for them, it's very similar to the previous architecture, but now we are proposing manage the switches with Catalyst Center. And we have some questions. Can you manage the switches with Catalyst Center for switches that are attached to SD access? And the answer is yes. And it can be managed by the same Catalyst Center or different Catalyst Center. It's the option of the customer. If you have the same Catalyst Center, you have certain advantage, like if you are doing TrustSec, you have centralized policy. So I wouldn't recommend a customer using separated Catalyst Centers to try to deploy policy, because then you will have two separate policy domains. Again, this one requires a strong collaboration between OT and IT. And then we move to this one, null byte ventures. This is the case in the example here. This is the case that they are completely flexible and can adapt completely to the new workflows. And this is the most fictional of them, because sometimes we get into this case is they think they are flexible, but they are not really that flexible. So when they go, and if you have full flexibility, then you can consider, let's extend the fabric to the below in the cell area zone. And that is where you see, at this point, extended nodes and policy extended nodes. And when we ask the customers why are they doing this, they think, oh, this is because I want to deploy TrustSec. So I will speak about this in a moment. But I just want to point out that the benefits of this architecture is that you have complete automation. You don't need to use any templates or campus automation to program your IE switches, to configure the IE switches. But then you have some cons. In this case, you have all the switches need to be managed by the same team. You cannot have a fabric in which one team is managing the fabric edge and another team is managing the policy extended node. They have to be managed by the same team. They have to be greenfield. The switches need to be new when they are provisioned into an SD access network. You cannot have a brownfield switch imported, discovered in an SD access network. And this includes the cases of where you purchase a machine that has a pre-configured switch. That switch can never be part of the SD access network because it's already configured. So with this in mind, I want to say this architecture requires, if you are doing templates in this architecture, configurations that are not part of the Catalyst Center SDA configuration, you need the approval of the design council. The design council is a group in Cisco that has SD access experts that will discuss your design and tell you if what you are doing will get you into trouble or not. The process is free. It's not a paid engagement. You just have to reach out to Cisco, fill a form, and there is some, probably it takes us like 1 or 2 months to give a response to you saying this is approved or not. And the reason is because when you have intent-based configuration and you are also pushing configuration into these devices, you can run into the problem of having 2 cooks in a kitchen. You may be overwriting configurations every time. And we have seen cases in which this overwriting of configuration will cause a conflict that will leave your switch in an unmanaged state. It's in an error. You cannot push anything anymore to it because the configuration is conflicting. So I want to close this section with this comparison between when to use policy extended node versus having a layer 2 switch connected to the fabric. A policy extended node is great when you have one team managing all, when you have switches that are completely new, when you onboard them into the fabric, when you want to use APIs, a strong, heavy user of APIs. But then the cases in which is not suitable, and we recommend a non-fabric switch, and this is why the most common case for our customers is when you want to deploy templates for it. For example, you want to run some resiliency protocol that is not, and at this moment we also support rep for SD access devices and a limited PRP use case. But if you want MRP, if you want HSR, this cannot be achieved by a policy extended node. If you have different teams managing the switches, again, this cannot be done with a policy extended node. SD card swap or SD card onboarding is not supported in a policy extended node. But I want to say that microsegmentation can be done even if your switch is not a policy extended node. The configuration to get microsegmentation is very easy to push via template, and it's also now available in the campus automation feature in Catalyst Center. So to close on the tale of 4 factories, this is a summary of where the customers ended up. There's 4 fictional customers in this journey. So if you notice this, there is a leg that is missing, and it's here. What happens when you want your control traffic to go through the fabric? It was not the requirement of any of the customers, but it's the case of our friend from Audi. So.
Yeah, thanks, Erica. Now we're looking into, after this fictional examples that we heard about, we'll look into what we are doing. And I want to start us off with a video into our manufacturing plant. This is in Neckarsulm in Germany. And more precisely, let's see if this is playing. Nice. You can also hear the robots moving and stuff. This is in our body shop where we're building the A4 and the A6. There's like one A4 that's being called A5. Someone messed up there. But normally, A4 and A6. And all of these robots are being controlled from the cloud. So there's no more PLC controlling anything of that. All of that is virtual. Oh, yeah, and I left like this whole shake in the end of the day, so you see it's not Gen AI or anything. So what is the main driver for what we are doing here? First of all, if you're looking into our factories of today, and most of you guys probably also have one like these, we see, first of all, programmable logic controllers, lots of them, oftentimes like thousands. These are, some people say, the brain. I think like more the heart of every factory because it like pushes data from A to B, like from a networking perspective. Then we have HMIs. There's still people next to the machines. They have to configure it, and there's like some disruption, so they go there, have to fix some stuff, right? But we also have industrial PCs. So these are hardened devices. They're usually there, hanging around and doing their stuff. In this case, maybe like a predictive maintenance use case. We also have computer vision for some quality control. I think many of you also employ that. Maybe some machine learning for tool control. We have some really cool use cases. And as you can see, we have more and more interesting things that we want to do, but also more entities that you have to manage. Like just think about your laptop that requires some updates and patches. We have to do that too in this environment with like 10,000 devices. and it's annoying to do with one device already. Now we have to manage 10,000 with no downtime, etc. So this is basically the challenge that we're trying to solve. And my colleague Henning has been here, like in Vegas 2 years ago. He said that it would be a maintenance nightmare if we are not changing anything, right? So we looked at this. There are many other issues involved into this. Maybe like the complex and cost is maybe obvious now after this introduction. Also the security risk in terms of patching. It takes some time to patch like 10,000 devices, maybe every week. You want to do that? I don't know if it's possible. And the inefficiency, so we have to focus on our sustainability goals like everyone else. And if you run these devices in the factory where everything is either cold or warm or hot, you have to have lots of cooling in some way or another. And this is everything. It's not really efficient from an energy perspective. Looking into our factory, and this is just like 2 examples here. On the left-hand side, we see the final assembling Berliner Höfe, where we produce like the RS e-tron GT. And there, oh, now I skipped a little part. We see these IPCs, these gray boxes, so these hardened devices, right? And what we're trying to achieve is putting them into a yellow cloud, as you can see here. On the right-hand side, you have a cabinet that's normally right next to these robot cells, the one that we saw in the video. And again, here we have this nice guy over there. It's a PLC, in this case, from Phoenix Contact, that we are also virtualizing away. So all of these devices that are presently on the shop floor are now moving into a data center. We'll get to that, how we did that. Now, speaking about PLCs, or programmable logic controllers, I saw that some people are from the IT side, so quick refresher here. PLCs are cyclically executioning, like running some type of code, and that in a cyclic manner. They are also, again, cyclically exchanging data with their respective process devices, such as a robot, some valves, and lots of security topics. Like, for instance, you have these red buttons, right? And if you press on them, then everything comes to a stop. This is all managed by PLCs with safety, human safety in this case. And all of these are communicating over a network. Traditionally, you have like your Profinet, Ethernet IP, EtherCAT, whatever. You run your shop floor, communicating with these guys. And that across many industries. Me personally, I'm from the manufacturing side, but I'm sure maybe there's 1 or 2 others. We heard like Disney, for instance, yesterday, who also have similar requirements. Looking into what we're doing now is we are virtualizing. And this is just an example, but it's a really cool example and a very challenging one. That's why I'm talking about this today. PLCs on a hypervisor. And there are different requirements that you have to fulfill when you want to do something like that. First of all, you require a real-time capable virtualization platform. And this has to be deterministic. So 24/7, it has to run without any interruptions, or else suddenly the IT for OT people are the ones who messed up, right? So we really want to make sure this is deterministic, not just the compute, but also the virtual switch. So in a virtual environment, you have also virtual switching. That one also has to fulfill some bounded latency and jitter requirements. Then on requirement 3, and this is mostly also where Cisco comes into play, connecting the data center, here named as an edge cluster, with the shop floor, is the, again, cyclic exchange of the data, again, based on Profinet, Ethernet IP, whatnot. And here, I think the highest requirement is the resiliency against failures, maybe like some switches or routers in between, or anything else might fail from time to time, an SFP even, and there you really don't want to have a robot come to a standstill. Just for context, if we lose 3 packets in a row for a given communication flow, then a robot comes to a stop already due to safety regulations. And these packets are coming in with a frequency up to like 1 millisecond. So basically for 3 milliseconds of an outage, networking outage, and your plant comes to a standstill. Sounds really crazy, but we still made it work. Finally, we have currently two partners we are doing this with, two VPLC vendors, Siemens and Codesys. Codesys is like a hidden champion from Germany. Now looking into the architecture, doesn't look too much different from what we saw from Erica. First, we have two clouds, right, left and right, two SDA fabrics in the end of the day. We have our, oh, okay, it's barely visible, the edge cluster in the middle that I just introduced. Just as an example, there's the VPLC again, virtualized HMI, because why do we stop with PLCs, the hardest one? We can also do the low-hanging fruits that are there anyway, and maybe some IDE, normally also present right next to the PLC, so why not also move that up into the cloud, right? Then we have this redundant architecture here, one fabric here, the other fabric there, and then we have our sale area zone. The sale area zone is basically unchanged. Like, we are very cautious about our brownfield migrations. We have a long history of manufacturing cars, right? So our plants have millions and I think even billions of like money that was gone into the manufacturing, like the buildup of these plants, right? And you don't really want to rip everything out and change it up. So again, like maybe another requirement for us was the brownfield integration here. Yeah, in this case, the one notable thing is the dual attachment of our extended nodes here. So let's do a little packet walk, because I really like packet walks to really understand how this all works. In this case, the VPLC is still generating its Profinet. Again, could be Ethernet IP, but bear with me, this is Profinet because we are leveraging Profinet and ProfiSafe as well, of course. And these Profinet frames are being generated by the VPLC. It goes down to the virtual switch, and here comes like the first interesting part. It's being duplicated. We are leveraging a resiliency protocol called PRP, Parallel Redundancy Protocol. Just takes the frame, duplicates it, attaches a trailer, and then you're good to go. If you want to learn more about that, you can ask Erica. Not me, I know. I can also talk about it, no problem. Then we are sending these across two disjoint paths at the same time. When we hit the fabric edge, we are encapsulating that into VXLAN. Again, sounds very complicated, but it's once you build it up, it just runs. Encapsulating it in VXLAN, this allows us to move these layer 2 frames over layer 3, layer 4 network infrastructure. These are being then transmitted synchronously, if that's a word. Then we go back to the fabric edge where it's being, the VXLAN header is being removed. So now we have our original packet, including the PRP trailer. Eventually, the first PRP frame reaches, in this case, the IE switch, where the PRP, let's say, flow is terminated. So we remove the PRP trailer, and at the end of the day, it comes out the original packet, and it's being transmitted to the robot where it's being consumed. So now we have like the other packet. What are we doing with this one? Well, it's redundant, so we just throw it away. Yeah, that's basically it. Pretty easy. Can also go into other way around. Just want to make sure that everyone understands what we are doing. Yeah, go ahead.
So Sid, let me ask you some questions I always get when I present these slides to my customers. So one is, you are doing safety over that.
Yep.
So do you need like the switches in the path to be certified for safety?
No, like say ProfiSafe in this case is a black channel protocol, so that doesn't really care what's in between. It really only cares the endpoints are Profinet certified, and that's about it. Yeah.
So how far is your virtual PLC? Is it in the cloud, or where is it?
That's a good point. Like this edge cluster that we see here can be like up to 10 kilometers away right now based on our deployments. You can, it kind of depends on how far it is. Like the latency in between increases by like 5 microseconds per kilometer if you use dark fiber, as we do. In this case, the maximum is 10 kilometers plus some other latency on top, so we are usually below 100 microseconds.
And how do you make sure you get your latency requirements through an SD access fabric?
Well, that's kind of a spoiler because we will get there later. But in the end of the day, it's, in my opinion, a mixture of quality of service and PRP. Yeah, we'll leave it to that, with that, but we'll get to that later.
Good. Thanks, Thomas.
Sure. Yeah.
So we talk about parallel resiliency protocol. I won't go into how this protocol works, but anytime if you have any questions, you can reach out to me. But I want to point out a key element of PRP that is used here, and is what we call a redundancy box or red box. So that's the device in the network that is duplicating these frames and then deduplicating them. So in this picture, the red box is red. So we had red boxes on the I switches on the cell area zone. Those are dually attached. And then we have a red box on the data center. If you notice, there is no red box on the top of this picture. That means the north-south traffic is not being duplicated. There is no duplication for anything that is non-critical. We are only duplicating the traffic from the virtual PLC to the cell area zone. And to achieve this, what we did is we created two networks, fabric networks, and in a layer 2, they are a mirror from each other. So when the layer 2 VNIs are configured, we make sure we use the same VLANs on LAN A and LAN B. But only one of these fabrics, in this case, Audi picked LAN A. LAN A is the only one with gateways because we cannot get out through the two of them. There is no red box on the top. So only LAN A has gateways. All the layer 2 traffic is duplicated, but anything that needs to be routed is not duplicated. It just goes through LAN A. And to provision this network, now we are, and I'm announcing this is a feature that is coming in Catalyst Center 3.1. We have a workflow that allows you to provision a switch as a policy extended node on LAN A, and then after you provision this as a policy extended node on only one LAN, don't connect it to the two until you have PRP, otherwise you create a loop. So only in LAN A, you run a workflow, and this workflow will guide you through the PRP options. And after that, you can connect this node, these to LAN B also, and have the resiliency. So as best practices, I like to call out this is, in order to run Profinet into this network, and we are using a layer 2 flooding, so we could potentially be creating like a big broadcast domain. So we want to make sure we are also using a new feature in Catalyst Center 3.1 that is now the ability of pruning VLANs in the trunks for the policy extended nodes. So that way we are only allowing the VLANs that are required in the cell area zone. And the second good practice is because of if you have a scale environment like Audi, there is a new feature also available now in iOS XE that creates this concept of PRP VLAN aware. That means PRP has some hardware, some tables are in hardware, so there is a limited scale for endpoints. If we use PRP VLAN aware, we make sure we are keeping those, we are only learning of the nodes we care about, so we are not oversubscribing these tables. With that in mind, I had a question also from Thomas before we moved. So we have to duplicate networks, and some customers say, okay, I have to duplicate networks. Is it really double the cost, or?
Talking about me with costs, like when I should point to Sven, who's like the project manager, he has to like say, okay, this is really financially viable. But in the end of the day, no, it's not double the cost. Why is that? The other fabric is much smaller in size. We really just leverage it for everything that's critical. And the other fabric, the main fabric, I would call it, that has also like layer 3 connection, northbound, that one is much larger in size. So that's why there's like a smaller overhead, 10%, depending on the size of your factory, right?
And I also want to point out that in some cases, when you have a policy extended node, you have a dual attachment to your fabric edge anyway, through a port channel. So if you are, instead of doing a port channel, you are using 2 ports to different fabrics, at the edge level, we have the same amount of ports than if we had a single fabric. So now the next question is, I talk a lot about OT and IT shared infrastructure. So what is our position on this? And this, I think this is also use case driven. We cannot tell you do a converge IT/OT infrastructure or do separated one, but we can tell you what are the pros and cons of each. So I will build a case for separated OT infrastructure, really risk adverse. I don't want my customers calling and saying that someone changing an access point messed up with their OT network. So in this case, I think having a dedicated SD access network for OT gives you isolation from changes on IT. So you don't have that kind of scenario. That being said, that doesn't mean you cannot install process on a shared infrastructure to make this risk lower. But it's just about assuming the risk. If you want to have the shared infrastructure, you have to be aware that there is a risk of changes in one thing causing problems in the OT network. So the second one is a separated OT infrastructure allows you to create customized policy. And that goes for segmentation policies, but also goes for quality of service. If you think in a shared OT and IT environment, usually in OT, you will prioritize your control traffic. On IT, you will give priority to voice and video. If you have shared infrastructure, I'm pretty sure you will give the OT traffic the priority. So now you have to deprioritize your voice and video. Again, this is a decision that has to be made, cons and pros, right? And finally, scalability. We have seen the case of some mega factories that the numbers of all the devices, if we put together OT and IT are way more than the scale of SD access of Catalyst, even the amount of devices that can be managed by a single instance of Catalyst Center. So that's a reason to split this into and have one OT and one IT. But then, what do you think, Thomas?
What do I think? Yeah, I mean, again, I'm German, so I like efficient solutions. In this case, I like a shared IT/OT infrastructure. I see the points that Erika just raised, but they are more like challenges as an engineer and less really, for me, reasons to move to a dedicated OT SDA network. And the first one, I just mentioned it, cost-efficient infrastructure. You don't have everything duplicated. I know it's kind of ironic because we are duplicating LAN A, LAN B for PRP, I know. But still, why do I need 3 of them all of a sudden? Just because IT can't really have their processes in order doesn't make sense. Then we have the simplified administration. Obviously, we have only 1 instead of 2. Like if eventually, like the scale of fabrics that you have to manage gets out of hand, it gets also harder to find the right slots to do that. You don't really want to do changes across all of them at the same time. And then finally, and I think this is also an important one, is bringing the IT tools to OT environments. We have lots of tools in the OT already. Let's say you're a Siemens shop, then you have your TIA portal where you can look into everything. That's great. But additionally, on top of that, IT has also lots of interesting tools that might even give you further visibility into your process, and it don't really have to look anymore what's going on. The solution will tell you, okay, there's like this and that cable is faulty, you should change it, that sort of thing, right? So yeah, these are the main drivers. I personally think this is the right way to do it. And now with that, no bribing or anything, but what deployment option do you think makes more sense? Maybe even specifically to your environment would be interesting, I think. Okay, let's see. Whew, okay. Okay, guys.
That's surprising. We did the same one in Amsterdam, and it was the opposite. So,
yeah.
Europeans, I guess.
Europeans. Who would have thought? Yeah, crazy. Okay. Yeah, moving on, maybe.
Yep. So I know you are deploying these dual fabrics for the OT traffic, but what will be the key thing that will really make you successful with this implementation?
The key thing, like let's say one of the key things,
okay,
I think.
One of the
right?
key things.
One of the key things in the end is visibility into what's happening in our network, especially in the OT side. Like depending on for which company you're working and your OT side has grown historically, you don't really know what's going on there. That's really something that we have to clean up usually when you want to implement something like network access control in OT, but you don't know what kind of assets you have, no MAC address, like some Excel sheets that are like outdated and stuff, doesn't really work. So there we are looking for some solutions, but at the same time we have this, and maybe I'm again talking about my solution because you asked me here. We have this somewhat complex infrastructure, right, with Edge Cloud here. Then we have this networking infrastructure, the shop floor, which is still there, producing, in this case, cars, and the applications on top of the virtual environment. So there are like many components involved in it. And if there's an issue, the guy at the line will just say, hey, there's an issue. Can you make it run again? Okay. So we have to look into all these points where we might have issues. And this is where like some, let's say, visibility tools comes into play. Might be Splunk or something else that ties all the different sources into one dashboard. In this case, maybe just as an FYI, we run a free shift 24/7 operations team that handle our EC4P platform. I don't think I even mentioned my project just yet. Like it's basically like a project to scale out this Edge Cloud initiative into the Audi group and then like VW group in the end of the day. Maybe lastly, the enhanced security posture. There's like a opportunity to use the network as a sensor because all of the data is flowing through it already, right? And I think Erica has like something that might help you.
Yeah, for that, many of you may have heard of CyberVision. But this is for the visibility challenge. This is our Cisco offering, the Cisco Industrial IoT offering. So if you want visibility into your network, we can, for example, expand this information and send it to a sensor to get information on what is connected. But these solutions are usually expensive if we are doing a span or if they are adding jitter into our network because we are duplicating the traffic, sending it somewhere. So in Cisco, we decided to make the switch be also a sensor in your network. So we can run a container into the switches, and with that, we can give you visibility. CyberVision does a DPI in the switch, or the traffic that is going through the switch, and then it analyzes in the sensor running there, and only sends one small percentage of data to a CyberVision center for analysis. So it's very efficient, and it builds your asset inventory dynamically. It also highlights what are the communication patterns between the devices. It gives you what are the vulnerabilities. It understands OT protocols, so you can see things as, oh, this is a Rockwell PLC, even this is the name of my program. You can say, oh, someone started the program, someone stopped, someone is upgrading the PLC. All of that is visible with CyberVision. And it gives you a risk score that is associated with the vulnerabilities of the device, but also with how critical the device is for your network. So with this, if you have red, you say, okay, I need to patch immediately. If it is yellow, you can plan for a patch. If it is green, no action needed. So it helps you identify where you should spend the time. So CyberVision in SD Access, this is a common question, is it supported in SD Access? And it is supported on Fabric Edge, Policy Extended Node, and non-Fabric. It runs in Catalyst 9300, Catalyst 9400, IE 9300, i3400, i3300 switches, and now with the new addition, the i3500 too. So the CyberVision is installed using the CyberVision management extension. And this is a plugin that is installed on the center. And the CyberVision Center runs on the shared services area, next to where the Catalyst Center is. You can now run, and this is new from now, you can run the CyberVision, the IP address of CyberVision can be in an overlay. Before we had the limitation that it had to be on the underlay. The advantage of this, for those that are familiar with CyberVision, is the case for active discovery. CyberVision is mostly doing passive DPI, but if you need to do an active discovery using very targeted OT protocols, like for example, Profinet discovery, you can do that. And if the sensor is in the same overlay than your endpoints, you can discover your Profinet endpoints. With that, I also want to talk about Cisco Provider Connectivity Assurance. This is for network observability. You know the finger pointing when something goes wrong is the network. What happened with the presentation just went out?
Yeah.
Well, yeah. Is it the network?
Finger pointing, right?
Perfect timing for the problem. Yeah, it is. We need PCA to find out.
Probably the OT guys.
So while this loads, the thing with observability is most times when there is a stop in the network, we don't know, is the network, was it the device, what is the problem, right? And if you have the right data and you are able to correlate the right data, that can give you actionable insights to be able to resolve your issues faster.
Before? No, before. You're too far.
So this is what.
This one is.
Yep, thank you. This is what Cisco Provider Connectivity Assurance is about. And you can install some, similar to CyberVision, you can install some agents into your network. They can be virtual. They can be hardware-based, pluggable, like in SFPs, or they can be containers. And you run these sensors into the network to send synthetic data, probes, testing your network. And you can send these probes in the milliseconds intervals. And I know Audi is doing a proof of concept of those, so I will let Thomas explain.
Sure. So again, we have our architecture, and I briefly want to give you another packet walk because we like those, right? We just heard from Erica, there's like two ways to deploy them. One is SFP based, so you have your standard SFP, there's like an FPGA on there, and then you run, in this case, I don't know, did you introduce TWAMP?
Nope, not yet.
Ah, you didn't? Okay. So everything is standard based, RFC 5357, and I will walk you through it, how this all works. So SFP is one way. The other one, which is a bit more interesting, is the agent. Basically has the same requirements as a VPLC when it comes to deterministic behavior, real-time, et cetera, communication. So with that, in this case, TWAMP is being initiated by an SFP that's here at the Fabric Edge side, connected to our servers. When this TWAMP packet is being sent out, it's being tagged with a timestamp, 1. Then it crosses the fabric, just as before our Profinet frames, to a destination SFP. This one is plugged into the IE switch. Once upon receiving, we tag it again with another timestamp, so we know, okay, time between 1 and 2, or like 2 subtracted by 1, you got the time delay of 1 way. Since it's the 2-way active measurement protocol, it will go all the way back again. We tag it another time with timestamp 3, crosses the fabric all the way into the SFP, where it's being tagged one more time. And then we have like both latencies, 1-way latencies across both SFP workflows. And this might be also from the agent, doesn't really matter where it's being originating from. and so you have all the precision. Maybe one thing to mention here is the precision that we are measuring this. It's on the microsecond level. So in our case, I mentioned it briefly, like we have double-digit microsecond latencies. And now if you want to measure something on that range, you need like at least single-digit microsecond precision of your timestamps, and then time synchronization between SFPs and agents. This is all being done by the solution. So there's no PTP or something involved. And if we look at the data, it's, I think, pretty cool to see. By the way, this is lab data. When it comes to our deployments, like 50 microseconds on top of that, right? Remember the 10 kilometers that we have between our cloud on the one side and the shop floor on the other. So on top, we see the end-to-end latency compared to the physical side. This is like, let's say, the Cisco infrastructure, and the virtual side, like this virtual switch that we introduced earlier. And luckily, also both of these, physical and virtual, add up to the end-to-end latency, in this case from the shop floor to the edge cloud. Then we have also here maybe like some spikes in terms of latency. Again, what I mentioned briefly before, since we have two ways, LAN A and LAN B, we can easily smooth them out. And the actual communication workflow or communication flow would only see, in this case, the blue one, otherwise the orange one. And lastly, like packet loss, also interesting to see, I think, on that level. Yeah, that's about it.
This is an interesting example of some things that are not visible. This hasn't failed. You have dual paths. Your PLCs are still running. But if for some reason your LAN B is not behaving correctly, it has some loss, and you lose LAN A, you are not really protected. So having this data and being able to monitor this data will allow you to take actions to fix LAN B before it becomes a problem.
Good point. Thanks, Erica.
Yep. So now let's move to the section of what are some challenges we have seen and how do we overcome this with industrial network, with SD access, sorry. So.
Yeah, the first one is from me, right?
Yeah. You give me some.
No, you can keep it for now. Yeah, like we can come up with all these challenges, right? But this was one of the most interesting one. It's the prioritization of the critical traffic. Erica, you already mentioned it before. So we're communicating over the SDA fabrics now with our critical network like Profinet, ProfiSafe. And there we require, as I mentioned, not only the latency in terms of like microsecond range, but also resiliency. But what's here about, it's the latency. And the key feature that we spoiled before is quality of service, which works surprisingly well. So
yeah. So most of our customers don't have quality of service configured in industrial networks because it's not really needed up to some point when we ask what is the utilization of your links. It's 100 megs, right? 200 megs, something like that in a 1 gig link. So it's not really needed. But as we put not only the Audi case, but more services into the network, you are collecting more telemetry and the pipes are getting more congested. Quality of service becomes really important, especially because we are talking about latency, jitter-sensitive applications. And if you who don't have quality of service, these applications will start to suffer. So the way we were able to preserve the priority of Profinet and ProfiSafe over the fabric was to, I will explain here, for Profinet and ProfiSafe real time, we are talking about a frame, right? It's a layer 2 frame. So we don't have the ACP values. But once we go into the fabric, it's a layer 3 network. And we prioritize based on the ACP. So the first thing we have to do here is to identify what is Profinet before it goes into the SD access network to map it into something we can prioritize through the fabric. So we use iter type, and then when we use iter type, we map this to a custom DHCP value. This is an example, the DHCP 52. It can be whatever is you want to map to. But this 52 is used in the network to make sure all anything with the DHCP 52 is put into the priority queue. And with this, it traverses the fabric with the highest priority. And when it egrets the fabric, we have to map again the DHCP52 before leaving the fabric. Make sure you are in the priority queue, but also make sure you put the right priority for a frame, which it will be the cost value. So the frame can move into a layer 2 network with priority. So this sounds like this is a standard QoS, but that's the way we are doing it in SD Access, moving from frames to layer 3. This is not a feature that is supported today by Catalyst Center via the UI. So all of these have to be deployed via templates. It's in the roadmap, but it's not yet available via UI. So that's the yellow note on the top. But to highlight the importance on this is in my lab in the network when we are congesting this network. It's a highly congested infrastructure at this point during a period of time that is highlighted there. We have in the left, we have packet loss. On the right, we have jitter. If you see the orange in this picture, for example, in the first one, is the packet loss for my best effort traffic. It's around 60%. The bottom line is my Profinet traffic, 0. It's completely protected by putting it in the priority queue. Same with the jitter. With jitter, we have maximum jitter for the best effort traffic in the order of 400 microseconds, almost half of a millisecond, right? For the Profinet traffic, that number is just 10% of that. It's around 30 microseconds. Yeah, 32 microseconds. So the second challenge is, let's talk about segmentation. Yep, sorry. So we have an employee in this company, in this scenario, that has a laptop, and it just opened the wrong email and can download the malware into his laptop. So the challenge here is that if this employee will connect this into an OT network and is not segmented, then this will propagate easily into the network. We can have some undesired behavior that will cause downtime. It can be a target attack to certain infrastructure. We can be stealing critical data. So the solution is always have a segmented network. This is not only for SD access, but it's a good practice to have segmented networks. By having segmentation, we can make sure Bob cannot reach these OT critical assets. And in case we know this laptop has been compromised, we can also put it into some segmentation policy that will further restrict the access for this device. But OT segmentation looks different than IT segmentation. And I want to call out what are the main differences I see that there are also challenges to resolve when deploying segmentation on OT. And the first one is sometimes, like in the IT space, we want segmentation on the port level. The most important thing is to authenticate the user is at the port level. In a manufacturing environment, we have like a zone-based process. If something fails in the zone, the process is down. And we don't want to interfere with the process itself. So sometimes what we hear from our customers is, I don't want to segment at the port level. I want to segment my east-west traffic, but I don't want it really at the access level because I don't want any, for example, zero-touch replacement to be delayed because I have that kind of segmentation. So that's one key difference. The second one is the support for 802.1x and the limited profiling on OT devices. It makes it different from the IT. And this is where cybervision may help. And sometimes if we are looking at profiling these devices, the more context we have, the easier they are to profile. So cybervision is able to get information from DPI on the OT protocols and provide this context to ICE, Identity Service Engine, for policing. Then another difference is in OT, we have this process-centric privilege. And what I mean with that is in the IT, for example, we have printers, and all the printers need to communicate with with the printer server, right? With a specific server. So, but that's common for all the printers. In the case of OT, I may have a PLC in one line exactly the same model of another PLC in another line, they have different communication requirements. This needs to talk with this process, this one needs to talk in another process. So it's not about what device it is, it's about where it is in some cases. What process is it associated with? The next difference is the static IP address assignment. As you know, probably you know the IP addresses most time are hard-coded in the program. There is no DHCP commonly for OT endpoints. So you have a static IP address. So you cannot use some resources that are used in the IT. For example, the concept of quarantine VLAN, moving endpoints to a quarantine VLAN if you want to isolate them, or having an onboarding VLAN, because you cannot change the IP address of those devices. So this limits our options in terms of how do we do onboarding. And those are all decisions that we have to make when we are designing. Do we want a deny by default policy because of this? So this is just to give you a hint of the things we think the most when we are designing policies for OT. And we have Cisco-affiliated designs that go over these challenges because this is its own separate session. We don't have time to cover all of this. But the last one here is TrustSec implementation is different from IT and OT also in the hardware support of the devices. Most people here knows that you don't only have Cisco switches on your OT environment, you have third-party switches too. Then, or you have Cisco switches, the cheapest one, to put it that way, doesn't support TrustSec enforcement, right? So we cannot enforce at the access port just because of that many times. So how do we build policy, and can we be able to segment with all these things into consideration? And one way we do that, and again, this is just a preview. There are Cisco-affiliated designs in this. And other sessions, I will show you the learning map is at the end. I can point you to some in TrustSec. But one of the most common deployments we see is we have a segmentation on an upper layer, like in a distribution point or in an aggregation point. So we don't really have TrustSec at the access most of the times. In this example, we have two different areas. One is the body shop that runs in VLAN 1060, and we have the paint shop that uses VLAN 1069. So the easiest is I will have a policy that just assigns VLAN 1060 to a security group tag. VLAN 1069 has another security group tag. So when I have traffic flowing into my network, I can enforce based on who wants to talk with him, with who. So if someone something in the body shop is trying to reach the paint shop, depending on my matrix, that must be denied. So this is the common example of east-west enforcement in OT. But then this creates also like a challenge. What happens with the device that actually need to communicate? We have interlocking PLCs, for example. So for that scenario, we can authenticate these devices, this interlocking PLC, for example, on the paint shop is getting authenticated to an interlocking PLC. Someone with knowledge of the process tags this device as interlocking, or you have some kind of profiling built into it, and it gets a different SGT from the zone. It gets SGT 30. So now when we are when something an interlocking in the body shop is trying to reach the paint shop, this should be allowed. But then, as you see here, the traffic is flowing. It gets to this fabric edge. Because it doesn't know yet, this fabric edge doesn't know that this is an interlocking PLC because it's not directly connected to it, this can be denied. And I wanted to bring up this challenge because it's so easy when people are used to IT TrustSec, they think it will be TrustSec it will immediately work, it will do what you want. But in these kinds of environments, you have to have extra considerations. If you are authenticating something dynamically, that is not in the enforcement point, you need to know the enforcement point. What is the identity of that device? What is the group that belongs to that device? So for that, we can use SXP. And this is a case in which we are using SXP in an SD access network. to communicate this tag to the fabric edge so it can get the proper treatment. So again, this was just a very quick preview of TrustSec. It's a whole topic, so I invite you to watch some of the recordings because I think the TrustSec session is already over, but I can point you to the one you should watch if you want to learn more. Another challenge is what happens when you have duplicated IP addresses. You kind of buy a machine, and most times these machines are cookie cutter from one another, so they have the same IP address. When I say this to some IT people, they tell me, oh, easy, just ask the vendor to change the IP addresses. And it's not the case, and sometimes it's done with an idea of mind. We want to have the same design so it's easy to maintain, easy to operate, right? But this creates a challenge because these machines were not used to have connectivity, to be connected with each other. But we need to connect them into this network to, for example, get telemetry from it. And we are talking now about connecting them to an SD access network. So can this be done in an SD access setting? And for that, we can use NAT on the switches. This example highlights layer 2 NAT. We also now support layer 3 NAT in some of our industrial switches, the i9300 and the i3500 that was just recently announced. But layer 2 NAT is a quick way to overcome this issue. Layer 2 NAT is called layer 2 NAT even if it is translating the IP address, which is a layer 3 function, so that creates some confusion. But the thing is, we are doing this on a switch port, on a layer 2 trunk, and it's a line rate. So that's a very big advantage for these environments because it doesn't add jitter to your traffic. Most time, layer 3 NAT translations, the traditional NAT, they are done in CPU, so they can add latency to your traffic. So layer 2 NAT can be used to, in this example, we have two HMIs with the same IP address, and we can translate them to a unique IP address so we can give access to these HMIs. In these examples, we are combining this feature with another one that is called interVLAN routing in the switch, basically. This is commonly done to avoid, to limit the broadcast domain. But this can be also done without the interVLAN routing. This is just an example. And I'm pointing this is because now, I will just build the slide first, because now we have some, yeah, that's there. So interVLAN routing with layer 2 NAT is only supported in some of our platforms. If you have the ones in the bottom, you have to use layer 2 NAT without interVLAN routing. So important call out. But if you are using the interVLAN routing feature, having a private VLAN and a public VLAN in an SD access environment, and that's the reason this is here, you need to have into account this important tip in yellow. You need to configure a setting on your IP pool that is called multiple IP per max. This will override the default security policy on SD access that limits one MAC to one IP. Because in this case, you are routing. Multiple endpoints are seen upstream with the same MAC, different IP. And that is considered a security violation. It is not allowed in Lisp. So you need to override this setting with the multiple IP to MAC. So the next example is we have Barney. He owns a process in the factory, and then suddenly production stops. And he suspects, well, it's my switch. So he goes, replaces the switch, but nothing happens. It's still not working. And every minute is costing money, right? So for this, one feature I want to highlight is the role-based access control in Catalyst Center. Most time what we see is our OT folks are not giving access to Catalyst Center. And we have the built-in role-based access control, the traditional, even gives you right away the option to add an observer role. You can give the OT people access as an observer of the network. But also in the new Catalyst Center 3.1, we have now role-based access control per site. That means, yeah, we have been waiting for this for a long time, but it's coming now, 3.1. So with this, we can give the, for example, permissions for network administration, for SWIM upgrades to OT users for a specific zone into the factory. So now this is,
Yeah, one more challenge that we came up with, basically motivated by the need of running L2 multicast traffic, which is required for like the, let's call it session initiation between a VPLC or like any kind of PLC with their respective process devices. This is, in the case of Profinet, done with the Profinet DCP, Discovery Protocol, that we heard before. And this one, as we are moving our PLC over behind an SDA fabric, we have to run this layer 2 multicast over it. And yeah, the question is, how can we do this? It's a pretty obvious one, but still.
But for this, we need to enable layer 2 flooding into a fabric. So the fabric by default is a layer 3, so it won't forward any multicast. But we have this possibility of using IGMP to send all the traffic, to flood this traffic through the SD access fabric. So how it basically works is the fabric edge will subscribe to an IGMP group, and this broadcast will be forwarded on the underlay. This is not only used for cases as the one Thomas was mentioning, but it's also important for silent host, which is coming next. So a silent host is a host that doesn't initiate communication unless it starts that first. And this is commonly seen, for example, when an endpoint is moving from one location to another one and is silent. So how do you know that the endpoint moved? Right? So we have this endpoint moving through the network, so how do we know that the endpoint moved? In Lisp, because Lisp keeps a database of the endpoints, and it has the endpoint registered in the previous location. So this is a challenge. But also, we have seen this even in wired endpoints, the ones that don't move in OT networks, for example, when we have layer 2 NAT. If you have layer 2 NAT, as the example below, and your device is not communicating, and you have this combination with inter-VLAN routing, your device will be silent unless it has any kind of routed communication, like an NTP server. So how do we know what is the location of this silent host? So for this, we have this option of having an IP-directed broadcast. This is a setting that is also configured on the specific IP pool. And with this, we can send a directed broadcast to the border node, and the border node will translate this into an Ethernet broadcast, so the device can reply to it and then be added to the database. The announcement I have below is that there is also another feature available that is called Lisp silent host detection. This can be configured to be able to do this inside the fabric. You don't need to go through the border node. But the challenge with this feature is that it's not yet available through the UI. So you will need to configure via CLI. So most customers prefer the IP-directed broadcast option. But this is a really cool feature. If you are having this challenge, let me know. We can talk about pros and cons of those. And we are doing well on time, 7 minutes to wrap up. So I wanted to go to what are the current challenges we still have to overcome with SD Access. SD Access was not designed initially for these environments, and we are moving into this. So what kind of challenges can we expect? And we already talked about some of these. I will say the first one is, can you have this control traffic over the fabric? And the answer is, unless you go with the Audi design of the two dual fabrics, very likely the answer is no, because you have, if you have an outage, you have a convergence time for 100, 250 milliseconds in this, while the layer 3 reconverges. Another one I want to call out is, again, quality of service. I cannot stress enough how important is quality of service, especially if you have converged networks. And it's not yet available from the Catalyst Center UI. So we have to go through a process of designing good templates and creating this process in how these templates will be pushed into the network. There are things that is just not because they are not supported, but we haven't validated, and I will be honest with you. One of those is IGMP for layer 2 networks. So if you have a Rockwell-based network and you are using multicast, this is not yet validated by us. We are in the process of doing it. Probably we will have some update by the end of the year. Things like layer 2 NAT are, again, they are not available immediately on the fabric, so you need templates to push these things. So with that, I want to pass it to Thomas to talk about what he thinks about the vision of the future.
Yeah. Sounds interesting, right? I will keep it short. I really look forward to a beer right now after this session, right? So write that into the comments if that's what you really want. But yeah, thinking back into what we just seen over the last 90 minutes, I think this is an architecture that really enables us to have a true software-defined factory. Many people have, I think, attempted it in the past, but I think most of them really stop at a certain point because they just say it's either not doable, it's not financially viable, etc. We have it in production. I think it kind of proves our point that it makes sense, and we hope that you also look into it, into adopting it, if it makes sense for your specific factory, manufacturing, Disney, whatever, right? And yeah, I hope it was interesting. You can always contact me or, of course, Erica, if you have more questions.
And before we leave, I want to have 4 things. I have 4 takeaways for you. And I think if you get something from this presentation is first, the architecture is there to support the use case. It's not about the technology. So you have to look at your drivers and pick the right architecture for your deployment. The second one is, actually, I have it in opposite order. But anyway, SDA allows you to have converged networks if you want, because it gives simplified macro segmentation. This is the main driver I see every time, like when customers approach me about SD access, is because most times they are going through this, so that's why I wanted to highlight here. But I don't think this is possible if you don't have a strong IT and OT collaboration. I don't think anyone should go SD access if you don't have that collaboration. If you don't do the upskilling, you need train the teams to really be able to run this network. And the fourth one is, if your main driver to move to SDA is TrustSec, I think you are okay in non-fabric. There are ways to deploy TrustSec without SD access. It's not the only way. I don't think that should be a driver to move into SD access. And I said this is the learning map. If you are interested in the TrustSec section, the second in this list is the section I recommend to learn about TrustSec on industrial environments. And finally, please complete the survey. This helps us a lot to know what to improve, if you like the session or not. So let us know. If you want a chocolate on the way out, I think there are some still available there. Yeah. Thank you.